So I'm about to tell you about actually some work we've done in something called the placements infrastructure that we use. In fact, I'll start right here. I'm this guy that runs this thing called assessments, and when someone actually wants to actually create a placements test, they can actually come on in here and actually indicate which grade they're talking about, and they can pick actually a bunch of skills. In this case, I picked 3 sitting here: adding and subtracting, non-integer, rationals. And of course, there's a prerequisite structure across 7th grade mathematics, right? You need to know adding and subtracting probably before you actually go on to harder stuff. And so I'm going to talk about this. And we have teachers that are actually using a computer adaptive thing called placements, which is our name for this, that will actually do a computer adaptive test based upon these skills. And then actually for every one of the topics that actually a child gets wrong, it will give remediations, and they'll have to get 3 right in a row on a given topic before they move on to the next thing. I'm going to talk to you about actually doing research to try to actually figure out whether we should believe the prerequisite arcs. I told you one that you all kind of believe that prerequisite probably exists, right? Like maybe you really need to know adding before you know dividing. But actually there's a bunch of others that are maybe a little bit actually, that might give you actually greater pause before you actually say this is what you should be doing. And so I'm presenting this work on behalf of my PhD student, and his name is Seth Adjei, and this is his talk. And present. Okay, here we go. It's also actually in collaboration with another student named actually Anthony Botelho. These are 2 PhD students at Worcester Polytechnic Institute. So I'm going to do the standard sort of outline. I'm going to tell you about our research questions. I'm going to tell you about our methods. I'm then going to but I'm going to warn you right now, our empirical results aren't very impressive. The reviewers must have actually recognized that the cool thing was what we were planning on doing next. So that will set the proper expectations. So I already told you the main idea of what a prerequisite graph is, right? And so you need to know one thing before you know something else. These are useful in a whole variety of actually reasons, and one of the if you live in America, there's this thing called the Common Core, and there's a prerequisite graph across the Common Core standards. And if I wanted to risk going on the internet again, I would click here and I would bring you to Achieve the Core, which actually shows you a graph. But all of these graphs, here's a portion of our prerequisite graph, and we actually have 180 boxes, so this is missing a bunch of stuff. Some of these are probably right, and some of them are probably wrong, and some of them maybe the arc should go in the other way. So what can we do? So Seth wanted to actually use pre-existing data being collected in the system to try to figure out what the graph should look like. His work is assuming that for each one of these boxes we have a skill builder that will give actually practice until students get 3 right in a row. If you went to one of our other talks where we actually allowed researchers to propose studies inside these remediations, those studies might be actually one of the remediations in and of itself. But we allow researchers to propose studies that I run on our 50,000 students. So if you don't know much about prerequisite structures, or if you do, you might actually probably recognize that actually there's a lot of work in actually what's called the Q matrix stuff. Tatsuoka goes back to a long time where, the psychometric type people like the Bob Mislevis looking at, okay, what are the items that actually are tagged with what skills? They call that a Q matrix, okay? I'm actually asking a higher level question, which is what are the skills and their prerequisite relationship? Not the question of actually, is this particular item actually with this particular skill? So I'm not the first guy to try to actually do data mining work to try to actually build better prerequisite graphs. Ken Kadinger doing learning factors, Richard Shyness. More recently, the researchers at Google and Stanford did a nice study where they applied deep learning to both Khan Academy data and assessments data. Our data is all publicly available, so I was really glad to see them use our data along with Khan's data to try to actually infer the prerequisite structure. They only reported on their attempt to infer the prerequisite structure across Khan Academy stuff, but we are actually replicating their work and seeing if we can actually apply that technique to our work. So that graph I showed you, maybe we could use some computer-based techniques with deep learning, but that just happened a few weeks ago. So I don't actually have, that's not what this paper is about. So this paper is trying to actually, trying to learn, can we learn which of these arcs should we believe? I showed you what placements is. I vaguely said it's a computer-based test that will actually that will roll back, and I'll show you a graph in a second that maybe actually will help you better understand that. But and eventually they'll actually also do, and after the test is over, then there's these remediations, one per scale until they get like 3 right in a row. So I'm skipping the video because I already had it up on the web, but after a placements test is done, and I was on the screen showing how a teacher made a placements test and assigned it to her kids, and I showed you, I clicked 3 boxes, I think. That means that every kid will get at least 3 items, but if every time they get one of these wrong, they'll roll back and they'll get another item on a prerequisite, if there are prerequisites in the graph. And as you kind of saw, our graph is very dense, and there's usually a prerequisite, because math is kind of like that. Once they're done, they get these remediations. You'll notice that actually this picture shows that there's 12 remediations the child has to do, and only 3 are displayed. So that's kind of how placements work. So I think I already alluded to the fact that actually if a child gets something wrong and maybe they get this one wrong and they get these 2 right, then it will roll back and actually check on D and E. If they get E wrong, it will roll back and check on an even deeper prerequisite, H. So Seth actually wanted to see, so he had some intuition. An arc is probably a reliable arc if actually there's a correlation between how long does it take you to learn a prerequisite to how long it would take you to learn a postrequisite. Meaning, like, if there seems to be no relationship between how long it takes, what's their speed in learning, then maybe there's actually, maybe this arc isn't a good arc. That's the idea. And so he used actually a simple regression model that actually, I'll refer you to the paper to little details, and I'll tell you why in a second, why I'm just referring you to kind of saying, he's got some model that is attempting to actually say which arcs are good and bad. Let's just imagine he's got something good there. He was looking to see that there should be a correlation between this thing that he cared about and that connects prerequisites and postrequisites. He comes up with some actually model that says, hey, 70% of these links look problematic. So he looked at, I think, 24 arcs in the paper. And so, all right, we've done some data mining, but where is ground truth here, right? And so what did he do? Well, he went and actually asked teachers. He got 21 teachers to go look at each one of these arcs and take pairs of questions and say, hey, do you think, and I guess we should be really careful about exactly what did he ask. How important is it that a student knows skill A to be able to answer a question from skill B? And so he collects data from 21 teachers and then actually looks to see what's the correlation between actually his measure of goodness and teacher measure of goodness. Let's just imagine the teachers are giving us a ground truth, and of course there's just massive variation between the teachers in and of themselves, so let's ignore that. So if you only look, if you say arcs are good according to teachers, if they actually clicked very important or extremely important, about 50% of the arcs are identified to be good by this criterion. I told you I'm not going to tell you the details about his little model, because when you actually try to use his model and this ground truth, we can't predict crap. Okay, we couldn't even beat majority class. So if you're a data miner, you're like, Okay, I'm glad you didn't waste my time telling me about the fancy model. So we've switched tracks, and I'm like, Seth, let's not actually do this anymore. Okay, let's not try to actually data mine our way to something when in fact we have the power to do randomized controlled trials. So we've switched tracks, and what we're currently doing is we're running a bunch of randomized controlled trials of actually several different types. And let me tell you about actually, excuse me for, thank you. So okay, recall that the graph looks like this. So we actually have 3 different randomized controlled trials that we're putting in. One is to actually say, let me tell you what's the order? To drop a prerequisite, yeah. So all the kids that get A wrong and also get E wrong, they're all supposed to eventually get a remediation on E. I, with like 10% probability, drop that. And I say, okay, you're not going to get remediation on E. We're just going to go right back to actually giving you, hey, try to get practice on A. And so by running a randomized controlled trial in this way, we can actually see, is there a causal relationship between actually getting a remediation practice on skill E and impacting A compared to all those students that actually did get remediations on E before doing A. And in my world, you can't get a remediation on A until you've done your remediation on E. And so I thought that was kind of a nice way of doing actually a nice randomized controlled trial. So that's actually, we call that the drop a prerequisite remediation experiment. Second experiment we did is actually, or second experiment that we built into placements, and it's running right now. So every teacher that builds a placements test, her students are part of the institutional review board actually procedure by which actually we are randomly experimenting on actually this stuff. And so second type of experiment he's doing is not to drop the prerequisite remediation, but swap the order. Let's actually imagine we got the order wrong. And for some of them, if you look more closely, you can think about, should this one be before this one? So with some small probability, all students are participating in one of these swaps as well. And so third type of experiment we're doing is, can we determine the relationship between prerequisite skills and a given skill? And so, yeah, right. This one's kind of cool. This one's like, well, so in the case of actually, let's say you got A wrong and you also got B and C wrong. We right now, as I think I showed you in the graphical user interface, that child had 3 things to do that was on his list. He could do them in any order. I'm not even sure how we randomly, how do we order them right now? But we're like, why don't we actually take advantage of the fact that actually, if we think they can do B or C, let's actually randomize that. And you're either going to get put into a condition where you have to do B first then C, or C first then B. And if you're like me, then you're like, ooh, that's cool. That's going to allow you to possibly determine that there should be an arc between one of those. And which way does it go? So we could possibly learn some new arcs. Notice in this world of building these arcs, you could actually use one of these graph building algorithms to try to actually infer all of this from data. But then we'd get all sorts of crap, right? We'd actually get and plus we'd be exposing kids to really stupid ideas. Hey, let's actually do calculus before we do adding whole numbers. And we'd all be like, that's stupid, right? And so we're trying to figure out what are the nice sort of like small tweaks you can do that are also plausible. And some of the other things we're thinking about doing is actually adding, remember how we asked those teachers what they thought? Well, let's use those as probabilities to actually figure out which ones are worthy of exploring. It's probably the case that you definitely need to learn to add before you learn to actually do division. But others of these maybe are more probabilistic, and we should. So those are the 3 things, 3 studies that he's doing that relate to learning the graph. He's actually also using this infrastructure to try to experiment with, well, maybe we should let kids actually decide. There's maybe some benefits of choice, but I could talk more about that. But I think I will. Actually I'll just conclude, and then we'll have plenty of time for questions. So let's learn what actually arcs are about, and let's actually think about not just how to use data, because I I do a lot of data mining, and I don't trust data mining as far as I can throw it. And so when this is a killer way of actually maybe deploying randomized control trials in an intelligent way. So let's get some questions.
Thank you, Neil. Is this working?
Yes.
It's difficult to tell. Okay. Somebody stick their hands up if it stops working so that we can...
Got one over there?
Oh, is that a question?
That's a question.
Oh, a question. You're not telling me the microphone's not working? I was going to say, thank you, Neil, for that high-speed presentation.
So sometimes, particularly in mathematics, you'll find that a previous subject doesn't really start to make sense until you start to apply it in a higher context. So how much have you been encountering that kind of thing when you speak to the teachers?
So, you know what that makes me think of? And maybe that's maybe what I'm about to say is related to your question. But us people always actually misinterpret the questions. But we have an interesting opportunity in the placements infrastructure to actually look as for dependent measures of actually how do they do on preparation for future learning. So as we're experimenting with actually what types of feedback to give them for E, what we actually have a free dependent measure of actually how do they do, how fast do they learn A after you've actually forced them to do E. And so we might find that there's certain interventions that we could do for E, and when I say interventions, like a video for information as opposed to text, we might actually find out that some studies, some of those might actually get learning for E to go faster, but that actually it hurts actually preparation for future learning, and they do worse on A, worse meaning it takes them longer to reach mastery. Other questions? Don't all jump at once. Yeah, Ilya.
Neat stuff, and it's good to see somebody actually experimenting with this, especially in academia, because there's been plenty of experimentation along these lines, say by people like Newton, but you might actually have open results.
And the mic just died.
Oh, you're loud, just speak loud.
Sorry, I'm just loud. I'll ask the same question that I asked of the previous speaker. So there's uncertainty here, right? So suppose you do your experiment, and for 25% of the kids, it's better to do A first, and for 75% of the kids, it's better to do B first. And that suggests what to you?
Well, it suggests first to actually do the one that is better on average. Do that first. Then secondly, let's see if we can actually figure out what are the characteristics of these kids. If we could predict actually from data that we already have, and in the systems we have gauge of data for their performance so far. If we could better predict that, then we could then personalize and attempt to maybe actually do better by, if we could accurately identify those children that are likely to do benefit one versus the other. But, I've spent my life actually doing personalization research. I've published like 24 randomized control trials. I'm always searching for results on actually which types of feedback are most effective. My wife actually gets pissed at me because I keep actually going back to a poster I had in the hall of a paper in 2009, one of the best winning papers of actually an AINET conference, where we actually find out, for high knowledge kids, you're better off actually doing this strategy, which actually is a cut to the chase strategy. Here, just read this and click OK, versus we'll break this down into steps for them. We all want to personalize the learning experience, but I just want to say, it's wicked hard. Okay, these new guys, the emperor has no clothes, okay? This is hard work, and I've been battling this, and my wife actually, she's trying to encourage me, and she's probably right, that actually the quality of success we actually have had in personalization at this level is very low. Like, I wish I could claim a lot more. So I want to do that, but the first thing I'm going to do, I'm not going to jump to the personalization step if I find that. I'm just going to first do what is best on average, and then later see if we can figure this out, because that's what we should first do, as a first order bit.
The more subtle issue is when it's 51% better versus 49% better.
Right. Then that makes me start thinking about then giving choices, right? Then when we have that low of information, then we probably should put an R between them and let them do it in any old order, or maybe since was having lunch with Phil Winnie, and I care about self-regulated learning, when instead of actually randomizing actually whether we actually give them, you know, A or B, and we have like no prior hypothesis, maybe the time is then give them a choice about that as opposed to me randomizing that. And because maybe there's a real benefit. I know that we've done another randomized control trial where we actually randomize whether we give choices or not give choices, and so I think there's a lot of cool stuff to be done there.
Any final burning questions for Neil? Go ahead. This isn't working. Just
Okay.
speak up.
I'm not sure that I can formulate it very well at the moment, but I'm thinking, you mentioned something about the intuition of teachers.
Yeah.
And I'm wondering whether you can use a set of teachers and their intuition about the order as a kind of a proxy of what a successful path looks like built up over time, and maybe that is something that you could compare? Is that something?
Yeah, so, right, and so I think I tried to say that in actually my wicked fast American sentence of 8 seconds long, where I was like, yeah, let's use these probabilities that these teachers are giving us.
Right.
When they're disagreeing, and they're heavy disagreement, well then we should be testing those arcs a lot more than when all the teachers agree. By the way, the teachers almost never agree on actually, well, it's 21.
But it's a good thing.
But yeah.
But doesn't that fall into the, you know, the idea of expert opinion that was discussed this morning? You know, like, do we actually rely upon a teacher's expert opinion versus the actual data?
Right, and by the way, and all this stuff about learning prerequisites or even learning actually Q matrices, it's all implicit on actually what is the normal progression that children are getting exposed to, like what is the textbook order, because that will also drive actually what this is. And so all of this conditional kind of on what is normal. One of my first papers I ever wrote actually was for a cognitive science conference, is where we basically showed that actually the thing that is taught in 10th grade in chapter 10 in the algebra book really should be put actually right before chapter 1, right? And so these insights can be useful, but then that totally screws up what the data looks like when we're using that data to try to infer what the relationship should be, because we'd never find it. So a lot of this is conditional. All right, why don't I pause and you can thank the speaker. Okay, who's next?